So from where I'm standing right now, which is about 12 feet, now all we need left for the measurements is to find the angle from up here to all the way up there. Alright, gentlemen, get over here. Can you film the numbers on? Of degrees.
Renzo stood 12 feet away from his house. Oh, its length x. So we're going to want to figure out x. If you were looking perfectly straight, his line of sight would look like this. And when he observed the top of the wall, his line of sight was like this. And with the chronometer, he found out that looking at that point, at a 50-degree angle of elevation, because the wall is straight from the ground, it stands at a 90-degree angle, and because this line of sight is from looking perfectly straight, these angles are also right angles. And because Renzo is standing straight up, these angles are right angles. Because these four angles are right angles, this is a rectangle. And the properties of a rectangle is that the opposite sides of a rectangle are congruent, which means these two sides are congruent, and these two sides are congruent. Which means that this side is 4.9 feet long as well, and this side, which is also the base of this triangle, is, because this is a right triangle, we can say that the tangent of an angle of the triangle is equal to the side length opposite of the angle over the side length adjacent to the angle. And we'll be using the 50-degree angle of elevation. This side length is part of this whole height of the house, but it's not the whole thing, because the whole height of the house includes this part, which isn't part of the triangle. So if we subtract 4.9 from x, we'll be getting rid of this part of the line, and we'll have the side length of just this part. And we can use that as the numerator in the tangent of 50 degrees. So tangent of 50 degrees, the numerator is x minus 4.9. And as for the denominator, it's the length of the side adjacent to the angle, which is this side, which is 12 feet long, so the denominator is 12. Then we can start solving for x to get the height of the house. So first we can multiply both sides by 12, which is the 12 times the tangent of 50 is equal to x minus 4.9. And 12 times the tangent of 50 is approximately equal to 14.3. So 14.3 equals x minus 4.9. Then we add 4.9 to both sides to get x by itself, which is 19.2. Which means the height of this house is about 19.2 feet tall. The fence is measured from 12 feet away, and the observer was 4.9 feet tall. And let's represent the fence with this line. The chronometer was used to observe this point at the top of the fence. And let's draw a line from here to the eye height of the observer. And when they're looking straight ahead, they look like this. So this forms a right triangle. Since Renzo was standing upright, these two angles are right angles. And because the fence is standing straight up, these two angles are right angles, which makes this a rectangle. Because the opposite sides of a rectangle are congruent, these two sides are congruent, and these two sides are congruent. Which means this length is also 12 feet long, and this length is also 4.9 feet long. The chronometer was used to measure out a 15-degree angle. And the whole height of the fence, we'll call it x, which is this part and this part of the triangle. So to figure out the height using trigonometry, we can use trigonometry to figure out this length equal to the side length of the side opposite of the angle of this angle 15 degrees over the side length of the angle adjacent to the angle 15 degrees, which is 12 feet. This length is equal to x minus and 12 in the denominator. Then we can solve for x to get the height of the fence. First, we can multiply by 12 on both sides, which turns us into 12 times the tangent of 15 degrees equals x minus 4.9. And 12 times the tangent of 15 is about 3.2. Then, to isolate x, we add 4.9 to both sides, which has 8.1 is equal to x, which means that the fence is about 8.1 feet tall. Okay, we can find the height of the space under the overhang like this. When the angle of elevation is measured, the scheme is like this. Is Renzo who was measuring the angle of elevation, and this is the wall of the book room, which has the overhang. Renzo stood 10 feet away from the wall of the book room, and he is also, because Renzo is standing straight up, these two angles are right angles. And because the wall of the book room is straight up, these angles are right angles, which makes this a rectangle. And because opposite sides of a rectangle are congruent, this side and this side are congruent, which means this length is also 4.9 feet. The length here from the wall of the book room to the end of the overhang is 2.9 feet. And the angle of elevation measured with the clinometer was 20 degrees. So, since the opposite sides of the rectangle are congruent, this side and this side of the rectangle are congruent, which means this whole length is 10 feet. Which means the base of the triangle is 10 feet minus this 2.9 feet, which is 7.1 feet. So, the length of this side of the triangle is 7.1 feet. It's because it's the total, the tangent of 20 degrees from this angle in the right triangle, because this right triangle would be the length of this side over the length of this side, the side opposite of the angle to the side adjacent of the angle. And if we represent the height of this space as x, this side is x minus this 4.9 feet. So, in the numerator we have x minus 4.9. In the denominator we have 7.1, because this length of the triangle is 7.1 feet long. To solve for x, first we can move 7.1 here by multiplying it to tangent 20 degrees. And 7.1 times the tangent of 20 degrees is about 2.6. Then if we add 4.9 to isolate x is about 7.5. So the height of the book room space next to the book room under the overhang is about 7.5 feet.